Hello friends, today in this video I will discuss about how to find two-dimensional convolution of two signals by matrix analysis method. So let's say X is a matrix. In MATLAB we have to write a matrix in this way, like start a bracket, then type the elements of first row, let's say 1, 2, and separate the elements by a white space only. Then to start a new row, type a semicolon. So let's say then 3 and 4. So because we can't write a row one above another, so we have to type a semicolon to represent a new row. So here X is a matrix and let's say H is another matrix. Let's say 5, 6, 7 and 8. So here X is a matrix and H is a matrix, and to find the two-dimensional convolution between X and H, just type conv2. This is a standard MATLAB command to find the two-dimensional convolution. Here we got the answer. In this method, when you practice 2D convolution, you can check whether your answer is correct or not. But let's say you got the answer wrong, so and you don't know in which step you did the mistake. So for that you have to see the solution stepwise. In this command like conv2 of X and H, you will just get the answer directly but not the stepwise solution. So to get the stepwise solution, I wrote a program. Here is the program I wrote to get the stepwise solution, and I hope you know the process or the steps of this matrix analysis method. So here is my class note. You can see this. Here is an example. Find the 2D linear convolution of the following signals using matrix analysis method. X is given 1, 2, 3, 4, a 2 by 2 matrix, and H is again 5, 6, 7, 8, a 2 by 2 matrix. So I hope you know how to solve this. So first step is find the dimension of the resultant matrix using the formula. So here this is the formula. Number of rows of the resultant matrix will be number of rows in X plus number of rows in Y minus 1, and same formula for number of columns. So in this case we got number of rows and number of columns are same. So in this case the dimension of the resultant matrix is 3 by 3. In the next step is determine the number of block matrices to be formed, which depends on the number of rows of X of Mn. Number of block matrices to be formed is 2. So let's name them as H0 and H1. The third step is determine the number of zeros to be appended in the block matrices by the formula. Number of columns in H minus 1. So in this case H have two columns, minus 1 is equal to 1, thus we need to append only 1 0 to the H, and then form the block matrices H0 and H1. So to form the block matrices, the H0 is the first block matrix, so which will depend on the elements of first row of X, elements of first row of X. So here is the block matrix H0, which is formed by the first row elements of X, and here is 1 0 appended. So here is H0 and H1. The next step is form the top list matrix. So there are two block matrices H0 and H1. So thus the top list matrix will look like this: H0, H1. Here these are not zeros actually, these are the zero matrices of the same dimension as the dimension of H0 and H1. And the next step is multiply A and H in columnar form. Here is the complete A, means the top list matrix, and H in columnar form 5, 6, 7, 8. So then just multiply this by matrix multiplication method, and after that you will get this resultant elements. So after getting these resultant elements, the last step is to rearrange these elements according to the dimension of the resultant matrix. Now what I'm going to do is to write a MATLAB program to solve this problem step by step. Here is the program, I already wrote it. And first let's see how it works. Just run it, and it will ask for enter the first matrix X. Let's say first matrix is 1 2 3 and 4. This is the first matrix, and the second matrix, let's say 5 5 6 and 7 and 8. Okay, so as you can see, we got the result step by step. Like it will say size of X is equal to 2 by 2, size of H 2 by 2, dimension of the resultant matrix is 3 by 3, number of block matrices to be formed is 2. Let's name this as H0 and H1. So here is H0. You can see H0 is formed automatically, and H1 again formed automatically, and the dimension of the block matrices is 3 by 2. Thus we need to add 3 by 2 zero matrix in A. So here is the A, and this is the H in columnar form, and after multiplication we got the resultant elements. These are the resultant elements, and the last step is rearrange the elements to form the final matrix of dimension 3 by 3. So thus here we got the answer step by step. Now I'll explain this program line by line. So first it will ask for the input, like enter the first matrix X, and this first matrix will be stored in a variable X. Then it will again ask for the second matrix, enter the second matrix H, and this second matrix will be stored in H. So this is the input function to take the input from the user. Now what is size of X actually? So in MATLAB, let's say X is a matrix. So when you type size of X, you get the dimension of X. Like here X is a 2 by 2 matrix, so we got the dimension 2 by 2. Let's say S is equal to size of X. S is a variable which will store the size of X. Here we get size of X, S is equal to 2 by 2. So if we type S of 1, means it will give the number of rows, and if we type S of 2, it will give the number of columns. So similarly in this way, S of X, we define a variable S of X is equal to size of X, and again sh, which means size of matrix H. So then fprint is a print statement. So this print statement is given to print the size of X actually. So here is the print statement, like size of X equal to, here n%d, and n%d is a space holder, and first n%d is takes the space for s of sx of 1, means for the rows number of rows, and sx of 2 means for the number of column. So this print statements will give us the number of rows and number of columns of X and H. Next, to find the dimension of the resultant matrix, let's say nr is the variable. So nr means the number of rows. So nr is equal to s of x, sx of 1 plus sh of 1 minus 1, means it will calculate the number of rows in the resultant matrix, and similarly nc will calculate the number of columns in the resultant matrix. So next step is Z. So here Z will calculate the number of zeros to be appended, and Z is equal to sh of 2, means number of columns in H minus 1, which will calculate the number of zeros to be appended. There is again a print statement which will print the dimension of the resultant matrix. So next, as you can see, there is a if statement, if else statement. So if what it says, s of sx of 1 is equal to 2 and Sx of 2 is equal to 2 means if x is a 2 by 2 matrix. Again, the second condition says that Sx of 1 is equal to 3 and Sx of 2 is equal to 3 means if it is a 3 by 3 matrix. So this program is valid only for 2 by 2 matrix and 3 by 3 matrix, because most of the time we have to solve 2 by 2 or 3 by 3 matrix. So what if we have to find a stepwise solution for 4 by 4 matrix? It's very easy, just you have to edit this code and some lines in this program. Just you have to edit some lines in this program. So here the condition is Sx of 1 is equal to 2 and Sx of 2 is equal to 2 means if it is a 2 by 2 matrix. So again we have to consider another condition, that if z is equal to 0 means if the number of zeros to be appended 0, then h0 and h1 will like this, and if z is equal to 1 means number of zeros to be appended is 1, then h0 and h1 will look like this. So how actually I define h0 and h1? So let's say x is a matrix. Here x is a matrix. If you type x 2 by 2 means you are going to extract the element of second row, second column. X of 2 comma 2 will give you the element of second row and second column. So similarly here I defined the h naught as x of 1 comma 1 and x of 1 comma 2. So here is just the definition of h naught. So I hope you already know how to define h naught and how to assign the elements to h naught and h1. So after defining h naught and h1, f print f, again there is a print statement to show the dimension of the block matrices is 2 by 1, and thus we need to add 2 by 1 0 matrix in A. After defining h naught and h1, we have to define A. So here is the definition of A. This is the definition of A, where you can see there is a command zeros 2 comma 1. So there is a MATLAB command zeros, let's say 2 comma 2 means if you type zeros 2 comma 2 it will give a 0 matrix of 2 by 2. If you type zeros 2 comma 3 it will give you a 2 by 3 0 matrix. So here is the command zeros 2 by 1 to get a 2 by 1 0 matrix, and here same zeros 2 comma 1 to get a 2 by 1 0 matrix. So now in the first case, if the x is a 2 by 2 matrix and number of zeros to be appended is 0, then h0 and h1 will look like this, and a is definition of a is this. So else if means it's the another condition under this condition. So if z is equal to 1 means the number of zeros to be appended is 1. This is the definition of h0 and this is the definition of h1. Now this is the definition of a, where you can see there is a command zeros 2 comma 3 means now in this case when the number of zeros to be appended is 1, then h0 and h1 will have the dimension 3 by 2. So in this case you have to append 3 by 2 0 matrix in the topless matrix A. So here is another condition where the x is a 3 by 3 square matrix. So most of the time in such cases the number of zeros to be appended is 0, that is we don't need to append any 0 to the block matrices, and thus the block matrices will be a columnar matrix in this form. So definition and the type of commands are same like the previous one, and in this case the definition of topless matrix is this. In this case, h0, h1 and h2 have the dimension 3 by 1. Thus we need to append a zero matrix of 3 by 1. So here is the command zeros 3 comma 1 to append a 3 by 1 zero matrix. So in both these cases, when X is a 2 by 2 square matrix or X is a 3 by 3 square matrix, or when the number of zeros to be appended is 0 or number of zeros to be appended is 1, we got the definition of block matrices and the definition of top list matrix. So now in the next step, what we have to do to find the H columnar, first we have to find the transpose of H matrix. Here ST means is transpose. So let's say X is a matrix, and to find the transpose of X, just type X and the upper colon means the X transpose. Let's define another matrix. Let's say T is equal to 1 2 3 4 and 5. So here T is a columnar matrix, and to find the transpose of T, just type T and the upper colon to get the T transpose. In the next line you can say H columnar is equal to HT, and within bracket there is a colon. So what it actually means? So let's say X is a matrix. So here X is a matrix. If you type X and colon under bracket like this way, you will get the X in columnar form. Thus this command will give the column matrix of H of T, which will be ultimately the columnar matrix of H. So now to find the resultant elements A cross H columnar. So to find, let's say X is a matrix and T is a matrix. Let's say X is a matrix and X dash is another matrix, which is the transpose of X. To find the matrix multiplication between X and X dash, just you have to type a cross to find the matrix multiplication of X and X dash. Here we got the matrix multiplication of X and X transpose. So by typing this command. So and finally there is an fprint command which will say rearrange the elements to form the final matrix of dimension n%d, n%d, nr and nc. So if you can remember, nr and nc, nr stands for the number of rows in the resultant matrix and nc stands for the number of columns in the resultant matrix. So after getting the resultant elements, means after getting the result of A matrix multiplication with H columnar, it will show a message to rearrange the elements to form the final matrix of dimension nr and nc, where nr is the number of rows and nc is the number of columns. So this is the overall program which will show you the stepwise solution of two-dimensional convolution problem, and this program is implemented using the matrix analysis method. So if you have any doubt regarding this, you can comment below. I will try to clear your doubt.